In the last module, I spoke about what is biodiversity and what are the different factors and how biodiversity is likely to be conceived as far as marine ecosystem or marine environment is concerned. And now in this module, I will be mainly focusing upon the different food chains which are known to occur and how the coupling of this particular food chain is responsible for increased diversity that is known to occur in the marine ecosystems. So in the marine environment, if you look at, we have pelagic ecosystems and then that of the benthic environment. Much of the and in the these ecosystems are normally known to vary with respect to the depth that is normally known to prevail in that particular habitat. So the pelagic ecosystems are normally considered to be a comparatively homogeneous systems where you find much of the conditions that are known to be uniform as far as the marine ecosystems are concerned, whereas you find much of the heterogeneity that is normally known to prevail in the deep sea ecosystems or in the deep sea environment or maybe probably in the benthic ecosystems. Now, in terms of the productivity or in terms of the production of the organic matter is concerned, the pelagic ecosystems are considered to be of significant importance because much of the productivity is likely to occur in the euphotic zone where the light penetration is likely to occur. Because radiant energy coupled with the supply of inorganic constituents is normally known to be responsible in generating or fixing a certain amount of carbon dioxide so that you have enough amount of organic matter which enhances the productivity of this particular ecosystems. So when we talk of the pelagic ecosystems, we find it is the phytoplankton-based food chain, which is normally known to be of significant importance, where a sizable amount of inorganic nutrients are basically being converted into the organic matter, which is going to be supporting a subsequent food chain in these particular ecosystems. So most of the coastal ecosystems where there is a substantial amount of nutrient flux, which is known to occur mainly from the freshwater input or maybe from the other sources that are or leaching of the land surfaces and other chemical weathering activities that are known to occur, they bring substantial amount of nutrients in the coastal waters, and these are basically referred as new nutrients which are responsible for much higher productivity that is known to occur. Much of this particular productivity which is known to occur in the coastal ecosystems is mainly phytoplankton based because it is normally known to be performed by the autotrophic production, that is the self nourishment which is normally known to occur, and as a result they produce a substantial amount of organic matter in the coastal ecosystems. This organic matter which is likely to be produced in the surface waters is one of the key component which supports much of the subsequent population of consumers like zooplankton and much of the diverse fauna that is known to prevail in the coastal ecosystems or in the oceanic environments. Most of the coastal ecosystems are normally known to be generating a high amount of biomass in terms of the primary productivity, whereas in the open ocean you find the productivity is much limited because of the nutrient depletion that is known to occur, and most of these open ocean ecosystems, they are normally being categorized as the oligotrophic environments. So ultimately, for a productivity or for a particular habitat where you find much of the diversity that is known to prevail, it must sustain a high amount of population in terms of the phytoplankton biomass, which is likely to occur in these particular ecosystems. In contrast, you have a benthic ecosystems or a benthic environment where the detritus-based food chain is normally known to prevail. Now, most of the detritus-based food chain, which is likely to occur in the ocean or in the oceanic ecosystems, is largely contributed by most of the organisms which are known to decompose a sizable amount of organic matter which is available in that particular ecosystem. Now, this has also a link with the overlying waters or the pelagic ecosystem simply because much of the organic matter that is likely to be produced in the water column is likely to sink into that particular ecosystem, and that becomes a substrate for the subsequent benthic or the detritus-based ecosystem that is likely to sustain. So in the sediment water interface or at any given point of time, you will find much of the particles which are produced in the surface are likely to sink, and then they accumulate in the sediment water interface where you find the activity of most of the bacterial population or the benthic organisms which are either deposit feeders or which are normally known to undergo a process of bioturbation are known to utilize this particular organic matter and evolve with the process of mineralization where the inorganic nutrients are normally known to be released by this detritus-based food chain. However, the supply of these inorganic nutrients in the benthic ecosystems or in the benthic environment is not going to be of much use, because you don't find the light is normally absent in these particular ecosystems, and therefore at a given point of time you would always find a pool of inorganic nutrients which is likely to occur in the sediment water interface or in the benthic environment. So it again depends upon some of the physical processes which are known to occur in this particular ecosystem, which bring about the movement of these particular deep waters, which are rich in nutrients, to the surface waters, thereby making these particular nutrients available for the primary productivity. And then you will find sequestering of certain amount of carbon dioxide, which is likely to occur with the help of these inorganic nutrients. However, in the coastal ecosystems or in the marine habitats, wherever such type of detritus-based food chain is normally known to occur, much of the productivity which is likely to be sustained is the regenerated productivity, that is mainly generated from the earlier synthesized organic matter which is accumulating in that particular ecosystem. Whereas in the coastal ecosystem, much of the productivity that is likely to come is mainly from the new nutrients which are likely to come from other sources, that is from the land or the riverine flux which is likely to occur, thereby contributing to a sizable amount of increased biomass in terms of organic matter available in that particular ecosystems. So as a result, you have a pelagic ecosystem that is normally known to be supported by the phytoplankton biomass or the phytoplankton population, whereas the benthic ecosystem, which is normally known to be supported by the decomposers or the benthic organisms or the detritus-based food chain. Now, in the marine habitat, you will find that there is a depth is one of the most critical factor which is normally known to prevail. Most of the coastal waters or the highly productive waters where the depth is comparatively less, you will find a better coupling of this particular food chains which is normally known to occur, because you will find that the depth is comparatively less in this particular ecosystem. So there is a better interplay between the pelagic ecosystems and then that of the benthic environment, thereby supplementing effect which is likely to be there in terms of the food chains which are propagated is much better in the shallow waters or in the waters where the depth is comparatively less. Whereas if you look at the deep sea ecosystems or in the open oceanic ecosystems where you find a depth to be comparatively large, the probability that the interplay between this particular ecosystems or the food chains which is likely to occur is ruled out or is very rare, unless and until there is certain physical process which is normally known to occur, and that will again terminate or influence the coupling of these particular ecosystems which are normally known to occur. Probably maybe the physical process like upwelling which is known to occur, which will bring about subsurface nutrient rich waters to the surface, thereby supplementing the primary productivity which is known to occur in that particular ecosystems. Much of the productivity which is likely to occur in the marine ecosystems or in the marine environment is also being subjected in terms of the euphotic is much larger in the euphotic zone, typically because of the mixed layer depth that is normally known to prevail. In the coastal ecosystems or in the coastal environment, the mixed layer depth is comparatively less, whereas as you move towards the deep sea ecosystems or deep sea environment, you will find the mixed layer depth to be comparatively high. When the mixed layer depth is comparatively high, it is possible that some of these phytoplanktons move down or sink down to that particular depth where light is a constraint, and therefore they will not be able to sustain or they will not be able to contribute to the organic production. Whereas where the mixed layer depth is comparatively less, where in case of shallow depths or in the case of shallow waters, you will basically find that there is a better interaction, and the phytoplankton, even if they sink to that particular depth, there is always the availability of light which will be above the compensation depth, and therefore they will be able to sustain or contribute to certain amount of organic production that is likely to occur in terms of the phytoplankton biomass. Now, if you look at the different processes which are normally known to occur as far as the marine ecosystems or the marine environment is concerned, here you will find that there is a great interaction that is likely to occur between the sea and then that of the ocean as far as sea and air interface is concerned. So what is very important as far as autotrophic production is concerned or the production of organic matter is concerned is the light and nutrients. However, a sizable amount of carbon dioxide is also important because it is ultimately the carbon dioxide that is normally known to be fixed as a source of energy, and thereby it is being converted into organic matter. The sources of carbon dioxide, if you look at, are mainly known to come mainly from the atmospheric interaction that is known to occur, and from the atmosphere we find a sizable amount of carbon dioxide that is likely to dissipate into the seawater. So the dissolution of the carbon dioxide which is likely to occur is mainly because of the air-sea interaction that is known to occur, and therefore you find the dissolution or the trapping of this particular carbon dioxide which is likely to occur in the aquatic ecosystem or aquatic environment. Now, as we are aware that typically you will find that this carbon dioxide is normally known to be assimilated by phytoplankton population, and then these phytoplanktons are normally known to be varying in size depending upon the nutrient availability which is likely to occur. And again, you will find that depending upon the nutrient availability, you will also find the larger phytoplanktons which are normally known to occur, and depending upon in the oligotrophic environments, you will find a smaller phytoplanktons which are normally known to prevail in that particular environment. And these are thereafter being grazed by the zooplankton population, either microzooplankton or the larger zooplanktons which are known to occur in the higher up in the food chain. Although much of the emphasis in terms of the synthesis of organic matter was largely being associated or focused on the phytoplankton biomass that was likely to prevail, but now it has been realized that most of these phytoplankton, they are also known to exudate a sizable amount of organic matrix or organic material which is mainly in the form of dissolved organic matter. And this dissolved organic matter is normally known to contain a high amount of volatile compounds which are highly unstable, and they are basically being lost back into the environment. And now it has been realized that this particular dissolved organic matter contributes to about more than 40% of the total organic matter of the world oceans. And now it is believed, or it has been demonstrated, that with the help of this particular microbial loop, which is mainly mediated by the bacterial population, which have got an ability to take up this particular dissolved organic matter within a short span of time and assimilate and then contribute or transfer that particular organic matter to microbial zooplanktons like ciliates and flagellates, and thereby this is likely to enter into the orthodox type of food chain which is known to prevail. And this concept of microbial loop, which was basically being floated, is normally known to act as a synergist in enhancing the energy value as far as this particular synthesis of organic matter or the propagation of the food chain in that particular environment is concerned. As I said, in the world ocean, one of the most important parameter is the depth that is normally known to prevail. And as I said, in the shallow water ecosystems or in the shallow water environments, the probability that the sinking or the time that is basically being spent by this particular organic matter is comparatively less as compared to the deep water ecosystems. In the deep water environment, you will find much of the there is a huge amount of time that is basically being spent by this organic matter which is likely to sink into that particular environment. And therefore, if the time spent is comparatively larger, then it is likely to be consumed by the different consumers which are normally known to occur in this particular water column. Whereas in the shallow water depths, you will find that the time that is basically being provided is comparatively less, and therefore much of the organic matter is likely to sink into the deeper waters. Now, it is also being, once the sinking process is normally known to be initiated, you will find that much of the particles which are not having a much nutritive value in the form of fecal pellets or exoskeletons or much of the carcasses that are basically being released by some of the organisms, they are being subjected to much of the sinking, and under the colloidal property of this particular water, they are normally known to form something what are called as aggregates. These aggregates, once they are basically being formed, they normally acquire increased density and then they sink at a much faster pace in the particular aquatic ecosystem or aquatic environment, and then they contribute to the burial or the deep sea ecosystem where the sinking is likely to occur. And therefore, as I said earlier, that in the deep sea ecosystems or at the sediment water interface, you will always find a pool of organic matter which is likely to be deposited from the overlying sinking process. Now, as this particular process are normally known to occur in the coastal ecosystems or in the open oceanic ecosystems, some of the physical process like advection or upwelling or the water movement which is basically being generated by tidal movement also bring about a physical mixing that is normally known to occur in this particular ecosystem, thereby keeping much of this particular material within suspension. And as long as this particular material is in suspension, they contribute in terms of the organic matter as far as its utilization in the aquatic ecosystem is concerned. In the deep sea ecosystems, once this particular material is likely to move beyond a depth of about 1,000 or 2,000 meters, they are normally known to act as a deposits in this particular ecosystem, because at that particular depth, much of the ecological interactions that are likely to occur is that at that particular depth are comparatively of lesser magnitude, and therefore such deposits are normally known to occur in certain localities or certain regions where they contribute to substantial amount of deposits which are normally known to occur in terms of the food chain. So as a result, you find that in the shallow water or maybe in the coastal ecosystems, there's a better coupling of this particular food chains, which is known to occur because of the reduced depth which is known to prevail, whereas such coupling in the deep sea ecosystems or at higher depth is likely to be not a very favored mechanism which is likely to occur in this particular ecosystems. So as a result, these are some of the processes which will also regulate the diversity or the abundance which is likely to occur in that particular ecosystem or in that particular environment. Thank you very much.